So we have a lot to cover today on the networking side. Oh, where's my remote? Okay, so I think last time we started with like basic networking stuff, like what is the IP address, what is the classless versus classful IP addressing scheme, how to create your networks in Azure. Now, a couple of things you need to remember from certification perspective is that you need to create your virtual nets if you're going to deploy physical resources like VMs, right? If you're not deploying the VMs in Azure, there is no need to create VNets. Okay, because if you're like deploying services, for example, app service or storage or SQL, they come with their own networking. You don't have to like configure networking for them. Okay, you create your own network configuration when you're going to deploy physical resources like VMs in that. Okay, and then set up with like other services which you want to use. So I think we covered subnets, VNet, core concepts. I think we did this lab as well, right? Like creating two VNets, one virtual network, two subnets, deploying two machines, right? And then connecting, pinging one machine from the other, right? To make sure that by default, all the machines can communicate in that VNet with each other, okay? And then you can say, put an NSG. So we talked about the firewall, right? If I want to disable, for example, outgoing internet, right? I can create an NSG, network security group, disable the outbound connection, and then I can apply that NSG at two levels, right? One at the NIC level of the VM or at the subnet level. Make sense? Right? So when you're given, like sometimes you might be given a scenario like this, right? Let me start my paint so we can. So you might be given the scenario something like this, that hey, your organization has some web applications, and then all those web applications also connect to the database in the backend, right? Now you need to design a network where all the web servers have inbound port 80 and 443 open, while all the database servers should not have any connections to the internet. Makes sense? How do you deploy that kind of security? So one of the ways to design that is something like this. So you create a VNet, for example. So let's say this is your VNet, right? Then you create two subnets, one for your web servers. So this is your subnet 1. And then another for the database server. This is your subnet 2. Why you will do it in two subnets? Because you have different rules to protect them, right? In this subnet, you want to allow the connections from the web, right? So what you can do is you can create a firewall here, right, at the subnet level, right? And then you can specify inbound, right? 80 open and 443 open. Makes sense? While here you will create another one and say outbound internet denied. Internet denied, so that database does not, anybody from the internet cannot reach to database, or even your database servers cannot go onto the internet.
So inbound and out.
Yeah. So this is
So only permitting S1 to go to S2.
Yeah, and then because they're in the same VNet, they can communicate with each other easily. Makes sense? And this connection is open anyways. because they
open automatically.
automatically, because they are both on the same virtual net. Okay, so you might be asked like this kind of question, like how do you design something like this? It covers.
So you really don't have to limit it by IP, for example, or by subnet. Like I just want those IPs for S1 too.
Yeah, so when you do S1, for example, right? So let's say your VNet is like this, 10.0.0.016, right? So you can have 65K computers here, right? 65K VMs you can deploy. So let's say in subnet, let's say you have 100 web servers to deploy, right? So you might create a subnet one saying, hey, this will have 10.0.0.0/24, right? So maximum you can deploy is 256 VMs here, right? And those 256 VMs will have this NSG in that subnet. Right. Same thing you can do 10.0. Let's say 1.0/24 for your database server. Right. So this is another one with the 256 VMs, right? Which has this subnet rules here. Makes sense, right? So since they're in the same VNet, they can communicate with each other. Now you have divided logically based on what kind of workload they are going to execute. Okay. So I think we did this and we talked about a little bit on routing as well, right? So when you want to route the traffic by default, right? There are certain rules which are applied on the routing table. So the routing table basically decides where is your next hop, right? So if a computer wants to connect to another computer, right? The first thing it will go to the router and say, hey, I want to send this packet to this address. A routing table will then look at all the routes and then decide what is the next hop. Is it within the network or is it outside the network? Or if it is outside the network, where it should go? Should it go to the internet gateway? Should it go to the VPN gateway, wherever it is, right? So all those rules you can specify in the routing table. Certain times what happens is routing table is used for, ultimately it is for creating the next hop, but a lot of times we deploy something called virtual appliances on the network, and routing table generally, might be sending the traffic to that virtual appliance. How it works, let me give you a couple of examples. So let's say we have this VNet, right? And we have this subnets here, right? And then we'll have a routing table. So routing table default route will be, default routes will be like this, right? All VNet, right? It will say the next hop is the in network. Make sense? So any traffic addressed to the whole VNet, right, will be inside the network, right? Because all of them can connect to each other here. Make sense? So when we say all VNet, that means this address. So for example, if my source address is like this, so this guy wants to send a packet to this destination, right? It will hit this route because it is in the same VNet, right? Make sense? So it can say, okay, your destination is in network, so you can directly reach that. Make sense? It could be routing it within the network. But let's say this guy now wants to connect to google.com, and let's say google.com's address is 202.10.5.6. This is not in network, right? So it might have another route called all other to internet. Okay, So first it will evaluate this route, okay? Since it doesn't match this condition, right? It will say there are only two rules here, for example. It says anything other than internal VNet, it will send it onto the internet. Means basically it will be sending it to the internet gateway appliance. And then from there, it will be routed onto the internet. Okay. So for example, this guy wants to go to the Google, right? It will be using this route information, and it will be, the traffic will be directed to the internet gateway. Make sense? But let's say it wants to go to something like, let's say 10.4.1.6. Now this is not an internet, nor it is within the VNet. So maybe it's some other VNet, right? You might have created. So this guy wants to talk to here. This will not happen. It will say it cannot connect because there is no route which is sending this traffic to another VNet. There's no links.
Can you do VNet pairing?
Yeah,
VNet pairing?
Yeah, so we'll come to that. Okay, so this is one of the examples, right, where it cannot do that. Or maybe some random address, let's say 100 dot whatever you're trying to get. It's supposed to be on the internet, but let's say that address does not exist or that computer is down on the internet, it will still not be able to go through. It will go through the internet gateway, but after that, it may not find a net stop. Okay, so that's what this routing table is all about.
Routing table like created by default, right?
Yeah, routing table exists by default with this system routes. If you want to, yeah, it is already there. So if you want to create your own routing table, you can create and then associate with the subnet. Okay, I'll show you like how to do that. But this is the next topic we want to get into. Virtual network peering means you might have created multiple virtual networks. Okay, depending on like why you would create a multiple virtual networks, right? Depending on your requirement to like segregate either the departments or the regions. For example, you might be a multi-national company, right? And you might have your resources in Europe, US, or Asia, and then you want to use Azure Cloud in all those regions, right? Now we know that the VNets cannot, span regions. Right, your VNet is bound to a particular region. So you might be creating multiple VNets that way, right, to support your multiple global locations. Right, so that's one of the reasons why you will create multiple virtual nets. Another is within US, let's say you want to segregate your resources, right? Maybe you want to create one VNet for your US East resources, one VNet for US West resources. But you don't want to use two different regions because of the cost purposes. You might be putting everything in a single region, for example. So you might have VNets in the single region, or you might have VNet across the region, right? By default, when you create multiple virtual networks in Azure, they cannot communicate with each other. Okay, so by default, there is no route for them to communicate. Okay, so what if you wanted them to communicate, right? In that case, you have something called VNet peering available in Azure. Okay, so what is VNet peering? VNet peering basically allows you to connect two different virtual nets on the Azure cloud. Makes sense? So if you created two VNets, right, you can connect them either within the same region or different regions. Okay, now when you do this, right, you have to understand a couple of things, right? So VNet peering is kind of a request response mechanism, okay, where one VNet is requesting and peering with another VNet, and then once another VNet accepts it, basically you have a route between them. So when you do this, basically a route gets created for you for both the VNets, right, to allow communication between the VNets. Make sense? This route is also created internally. You don't have to create the route. As soon as you do peering, the route will be created for you. Okay. So you, again, it has like two naming conventions: virtual network peering, connect virtual networks within the same region, or global virtual network peering, where you connect virtual network across the region. Make sense? Okay. So you can do this. Now, let me show you how to do that as well. So, and then we'll talk about the gateway. So if you have your portal open, let's get to there, and then you can create two Vnets and do the peering between them. So what I'm going to do is I'm going to create two virtual networks, and we'll do the global network peering. So one on the east region and one in the US West region. Okay. So in order to create a virtual network, you can just put Vnet. And I'm going to create one in the US East region first. Again, creating virtual network does not cost you anything because it's just a definition. And when your resources get deployed into the virtual network, those are the resources you get charged on, but not for the creating the virtual network itself. Okay. So let me create a new resource group for today. Let's say labs. And then I'm going to say Vnet East. In the region, I'm going to do US East or East US. Right? Again, remember this steps. Sometimes they will ask you these steps, right? Like what are the steps to create this, either through a portal or a CLI, etc. But generally speaking, when you create a Vnet, right, the two things you need is the name of the Vnet and the region where you're creating the Vnet, right? Most of the other things are optional or it has the defaults. For example, if I go to the IP addresses, by default 10.0.0.16 is there. Right? So I don't have to specify it. If I don't specify it, it will pick up the whatever is the next available recommended one. Okay. So this is the recommended one. I can take that, and you see by default it creates a default subnet with the 256 servers in it. Means with the 256 server space in that. Okay. So I don't have to actually specify any of these unless I want to change it. Unless I want to change my.
When you create the second one, it has to be different.
No, it doesn't have to be different. You can have because these are all private IP spaces. You can use the same one. Okay, but then you might get into problems when you want to do peering and things like that.
Yeah, that's what I'm.
So if you're trying to, if you had a plan to do peering maybe in the future, then it is recommended that you use a different IP spaces. But it will not stop you from using the same space for a Vnet.
Yeah, I got
Yeah.
that. I was just talking about like if you're going to do peering, it has to be.
Exactly. I'm going to create this first. And once it's created, we'll create another one in the US West and then do the peering between those. So Vnet East is created in the East US. Okay. Whenever the VMs are deployed in that, if you want to see, there's something called connected devices. So you will be able to see if VMs are deployed in that Vnet or not. Okay. Now let's go ahead and deploy another Vnet in the US West region. I'll do that one. Just that. And I'll change my region to. Okay. If I go to next IP addresses, you will see that has changed to 10.1.0.0.
We did.
Right? So it recognizes that all your VNets are there, and then based on that, it will use a recommendation, the next available one. I can change it back to 0, without a problem because it's a private space, right? But then it will create conflicts later on, right? So it recommends that, okay, you have a separate one, okay? So I'm going to review and create here. Let's go to a resource. Okay, so it's in the West US, right? We have created a different VNet. Let's look at a few other things. Okay. All right, so now we have two VNets, right? Let's say I want to do the VNet peering. So let's see this diagram. Sometimes you might get a diagram in your certification exam as well. Then based on the diagram, they might ask you questions. So if I want to create a VNet peering, right? What you need to do is search for something called peering. You can start from here, or you can start from a given VNet as well. Okay. For example, let's say I'm here. And you see a peerings here, right? If I go to VNet web and I say peering, it says there's no peering right now. Means you cannot connect to another VNet in Azure right now. Okay. But let's say I want to add it from here to, let's say, US East. Right? You can start from here as well. You can say add. And then you give a link, right? So by default, the peering link is to bidirectional from both VNets. So you need to provide the properties for both of them. Okay. So if you see a peer link name, I'll just say, peering link between West and East VNets. Right? It could be anything like HR and sales, for example, or Asia and this region, right? And then you have to answer these three questions, which is important sometimes, okay, when you're designing it. One is saying traffic to remote virtual network, do you want to allow or not? Definitely we want to allow that, right? So by default, it is saying allow. There are two more questions here which are interesting. Traffic forwarded from remote virtual network. What it means is if your remote network is forwarding traffic from some other network like a VNet, etc., do you want them to connect with you as well? This sets up a transitive dependency between the VNets. And I'll show you like what it means, but by default right now it is allowed. Okay, the transitive dependency kind of is allowed by default. You can stop that. You can say no, I want strictly VM servers between only these two networks to talk to each other, but not any other network which is able to talk to that network.
So transitivity is allowed.
Allowed by default.
By default.
Yeah. So which creates some interesting scenarios. We'll talk about that. Okay. They say virtual network gateway or routing server. Okay, what it means is that do you want to use a peering network to, if any gateway is deployed on that particular network, do you want to use that routing or gateway to go out and connect to other devices outside that network? Okay, so that's another scenario, but right now it is saying none. Okay, so right now we are saying that we'll not allow that.
This is outbound.
This is outbound, but it's both ways. You can select. I'll show you that.
So do you want the rule of both routers for the VNets to apply to both?
Right. And then you say remote virtual network peering link name. This is the other direction. This is like, this direction is like from west to east, right? And then you specify this from east to west, right? So you can say, hey, you link east to west.
You don't have the same option.
Okay, you have the same option. Okay. But when you do that, you have to specify which VNet. So let's select VNet East. Right? Yeah.
Well, we went from
We went from the west, it didn't ask for the first one, the source link, which is the target link, and the same question. Okay. And then you add it here. Typically, it's a request response, but since you are the account owner and in the same subscription, it will automatically create the two links. Okay, so what it is saying is,
what happened if there are two different systems?
then you have to do a request, and then from other subscription, somebody has to respond to that. Like in AWS, I think you do that. Yeah. If you see that we are saying, okay, the link is getting set up, but the gateway transit is disabled because there is a none in the gateway transit we selected. Okay. So that's how you set up a peering. Okay. Once it is done, what I would ask you as a homework, what you do is like once you've created this peering, it's not going to cost you anything as of now. Okay. What you should do is just as a homework, deploy one VM each of them, right? And then try to ping each other and see if that route is working or not. Makes sense? Okay. So you will know like how you connect two different virtual networks within the Azure cloud. Make sense?
You have to create subnets and else.
Subnets are already created, default subnets are created already. So because when you create a VNet, it should have by default one subnet, right? So there's a default subnet already there. Just deploy a VM in the default subnet, and then ping the other VM from there. Okay, so far so good. Questions? So now if you look at that, it's going to show you how it is. So right now it is saying it's fully synchronized, peering status succeeded. So now all these things should be working.
You can change it.
Yeah, you can change these parameters later.
If they were different, they will give you two options.
Yeah. Yeah. So that's how you create a network to network communication. Okay. You can do unidirectional or you can do bidirectional. If you wanted to do unidirectional, you would just say disallow, disallow, disallow instead of allow, allow, allow in those in one of the directions. In the second.
And that's wonderful. You're, controlling both directions.
Right. So basically what happens is like when it is bidirectional, right? Both the VNets have a routing table to go to the other one. If you're unidirectional, only one gets routing table, but the other does not get the routing table. Makes sense?
The special thing here in Azure is like the transitivity.
Yeah. Yeah. So transitivity sometimes is very, very important in certain architectures in Azure, and that's why they allow by default. Okay, we'll talk about that in a bit. So this is VNet to VNet. Now, you can also do a hybrid networking, right? Hybrid networking means you have certain resources on your on-prem, right? And you want to extend that into the cloud, right? How do you do that, right? For that, you use something called gateways. Okay, so a couple of things to remember before we go here. When you do this VNet peering, right? All the traffic between the two VNets, right, will be taking a route, right? It has to go over some network. Makes sense? So let's say you have two regions. You have US region West, you have US region East. Now you connected those, right? But then the connectivity both between those two regions, right, has been established by Microsoft's Azure networking, right? Or sometimes it might take an internet route. Makes sense? Right? So if you want to connect from, let's say, California to, let's say, New Jersey, US West to US East, right? By default, it uses a Microsoft networking, right? So there's still kind of a private connectivity between them. Makes sense, right? Sometimes if needed, it can use the internet route as well, from going from one region to another region. Okay. In both the cases, one thing to note is your connection is not secure. Okay. Unless you use like HTTPS, etc. But like if you're using the TCP or any other connection, right? By default, it will use the Microsoft networking. So that way you're kind of secure, right? But your traffic itself is not secure, right? So if you wanted to secure the traffic, you need to encrypt the traffic between the two regions. Make sense? Right? That's where the VPN comes into picture. Right? Generally, when you have two private networks, right? You connect between the two private networks. When the traffic flows, right? The traffic flows without security, encryption. Okay. If you want to encrypt that, you need to introduce something called a VPN in between. Right? So like when you're working from home to the office, etc., you might have seen that you have to do a VPN connectivity. Right? Why the VPN connectivity? You can go to the internet to your office location, right? But the problem is your connectivity is not secure, right? So one of the VPN's main function is to encrypt your traffic. Makes sense? And then second function is to provide you with the proper routing table, right? When you like connect to your office network, right? Where you can go, then your routing table gets updated based on that. Okay. So if you wanted your VNet peering to be secure, right? That's not an option in the peering. Okay. So you have to be careful when you're designing the network. If you want your virtual networking connection to be secure, you might have to deploy something called a VPN gateway. Okay, and peering may not work in that case. So what you do is,
But that's because you are connecting to your site.
no, I mean, even if it is not a site, right? For example, in Azure, right?
Even
Inside like Azure Cloud,
Vnet to Vnet,
yeah,
it's not secure.
it's not secure. So for example, let's talk about this. So you are in Azure, right? A simple case, let's say you are on Azure West region, West US region, right? And you created two VNets here within the same region, right? So VNet 1, VNet 2. If you create a peering between the two,
The connection is public.
this connection is not encrypted. It's not a public because both of them are within the cloud. So it's not going to go out to the internet to connect with both of them. Make sense?
So it is private to
It is still private because it is using the Microsoft network, right? But the only thing is the traffic which is flowing is not encrypted. Make sense?
All right. Okay.
Right? So for example, when you do HTTP, you do HTTPS, for example.
But who
right?
can connect there?
Hmm?
Who can connect there? Nobody.
We don't know. Like, you might still have eavesdropper within the corporate, right? It's not they don't have to come outside from the corporate. Makes sense, right? So if you wanted to secure this, the peering is not a good option. What you can do is you can do the same thing by doing a VNet to VNet connectivity by using a gateway, VPN gateway on each side, which would be able to encrypt your connection and send the traffic over.
It's a security for inside.
for inside.
Because I was thinking like, it's not private for Azure, so you are exposed to the whole
Yeah.
internet.
So let's expand this concept now. What this concept allows you to do is a VNet here. Let's say you are into Azure-based region, right? And you have an office location in on-prem data center. Let's say somewhere in Arizona, right? Now you want your office location network to be expanded using Azure, and you want to expand that through this VNet connectivity. Now the problem is this traffic from here to here is using internet, right? Concept is same. You want to secure end-to-end encryption, you deploy VPN gateway here, you deploy VPN gateway and secure the traffic.
They give you the option for
Yeah. So the other one is like, if you are not comfortable with, even with this, you can have something called an express route, which is basically a private connection between the nearest region and your office. So it is called express route. Make sense? These are all the possibilities based on what kind of security you need. It is possible that you want to connect your HR department to sales department without much of the problem because they are the same cloud. You can just do a peering between them, right? But it could be that, you might have some sensitive material here and something, outside internet connections under this VNet. Now you want to encrypt this network, you can do a VNet to VNet through a gateway, VPN gateway, right? So when you do VNet to VNet using the VPN gateway, we call it VNet to VNet connection in Azure. If you do this, we call it VNet to site connection. VNet to site connection. Make sense? Okay. So remember these terminologies because sometimes you might ask in the certification question like, how do you implement site to VNet connectivity? So what they're talking about is the hybrid. How do you implement VNet to VNet? This VNet to VNet is not a peering. VNet peering is a different concept. VNet to VNet connection is a different concept. VNet to VNet connection is basically based on the VPN gateway. VNet to VNet peering is for connecting the two VNets without a gateway. Make sense?
It would be like one button.
Yeah. Okay, so that's where the gateway comes into picture. So as soon as you put the gateway, it provides you a security layer. And there are different security layers you can select based on the SKU you use in the Azure, but it will be based on the latest IPsec versions, and you can create a VPN tunnel between your offshore. Right? Generally, when you do on-prem to this connection, it will always be through VPN gateway. It will not allow you peering between the two. Okay. Peering is a good option if you're in the same cloud, same region. But if you want to go outside, you use the gateway. Makes sense? So that your communication is secure. So when you talk about the on-prem connectivity to the cloud for creating a hybrid network, it has to be secure, and the only way to get through, or only way to get through that is through the secure tunnel like VPN gateway. Okay. All right. So let's see how do you set this up. So let me show you that. So let's say we have VNet to, we want to establish a VNet to VNet connection between east and west instead of peering connection, right? So let's do that.
In this case, it will allow you both.
Hmm?
In this case, it will allow you both.
Yeah. So Let's look at the VPN gateway. Okay, so that is to do it, and this might be one of the things you need to look at. So let me go to the one of the VNet. So let's say we go to the east first. Okay, and I want to create a VNet to VNet VPN gateway or VNet to on-prem. Generally, the steps are same. Okay, so first thing you need to go to a subnet. So VPN gateway is a device. It's a virtual device, right, which gets deployed on a particular network, right? So when you do this connection, right, connection like this, you see that you need a VPN gateway appliance deployed into your VNet. Okay. Now, when you deploy this appliance, right, it needs its own subnet. So like your VNet, right, in that VNet here, let's say you created 10 subnets, right? When you want to do this VNet connection with the on-prem data center or some other VNet for the security through the VPN gateway, you need to create a separate subnet called a gateway subnet. Okay. Without a gateway subnet, your VPN gateway will not be deployed. So that appliance gets deployed in its own subnet within a virtual network. Okay. And the reason for that is that it needs to have its own routing, security, etc. setup, and it does not want to disturb all other subnets which you have created. Okay, and that's why you would be doing this. So if you go to any of these VNets, right, we have subnets here, right? You see here, there is a one plus here called a gateway subnet. This is very important. Okay, you need to have a gateway subnet in order to deploy your gateway appliance like VPN gateway. There are different gateway appliances you can deploy. One of them is a VPN gateway, another is called a local gateway. Okay, so in order to create a secure VPN gateway, you first create a gateway subnet. So you click on here and say, I want to create a gateway subnet. So based on how many IPs you have used on other subnet, etc., it will give you a recommendation that you can create a subnet like this. Now, gateway subnet doesn't have to be 256 servers. So by default, it is saying you use this subnet range, right? But the gateway subnet is only one appliance with certain rules, right? So you can go as minimum as like 27-bit mask or 29-bit mask if you're running out of your address space. If you're okay having these 256 servers here, you can take this one, or you can change it to 27 or 29-bit mask. Makes sense, right? So that's the first thing you will do, and then there are a few things on that. Like if you wanted to create a custom routing table on that and attach to that, all of that can be done. Okay, but by default, you create a gateway subnet and then click on save. You have to do this on both sides.
To create another gateway subnet.
So you'll have to create a gateway subnet on the west side as well, right? Because this is not going to be a secure connection between two VPN devices. Makes sense, right? So you have to go to the US West and also create a gateway subnet over there. Or if you're on on-prem, you have to deploy a device called a local gateway or a VPN gateway. So it could be a physical, it could be a virtual, right? So you basically, deploy that onto your on-prem data center, right? Once you have that, you need to tell each other what is their address so that they can communicate, right? Makes sense? So it needs to be a public address, right? So first step is to create a gateway subnet. Okay, let me create a gateway subnet for VNet East as well. Sorry, West as well. I go here, I go to the subnets. Now go here, create a gateway subnet. Right, so now you have prepared two subnets where you can deploy your VPN appliance. Make sense? So once it is done, you can deploy your VPN appliance on each of those subnets and then say, I want to connect these two now. Okay. Now what you will do is you can say Vnet gateway. Oh, okay. You see virtual network gateways? This is the appliance you want to deploy now. Right? You say, okay, I want to create a virtual network gateway. So click on create. We'll say, okay, what is your gateway name? So I'll say this is the East gateway. Make sure that your regions are correct, where your VNets are there. So let's say I want to say East US. You see here now, there are two radio buttons. This is very important. Your VPN and Express route. When you select VPN, that means it's assumed that your connection is over internet. Right? If your Express route connection, you can specify your Express route connection this. Right? This is what I was talking about here. If you have a private Express route connection, you say my traffic is going to come over the Express route. If you say VPN connectivity, it's basically assume that you'll have this kind of a connection through internet. Makes sense? Or a Microsoft network. So this is very important. Your gateway type is VPN or Express route. VPN is like kind of a public network on which you are encrypting your data. Express route is a facility provided by Azure where you can have a private link between your on-prem data center to the nearest Azure region through partners. Okay. So we don't have Express right now. Right now, we're going to use this as a VPN gateway. Okay. And then you see the C SKU. The SKU basically tells you how much, or what kind of security will be applied on that. And there are like different ways. You can go for a basic, like if you want like a basic security with not a lot of cost, but it will still be secure. Okay, and then other SKUs as well. And then you select a virtual network on which you want to deploy this, right? Okay, so you say, okay, I want to deploy this in the Vnet East. It will automatically identify if your gateway subnet or not. Yes, if you do not have, it will say, no, you don't have a gateway subnet, I cannot deploy this appliance. So this is very important. You need to have a gateway subnet in order to deploy a Vnet gateway. Okay, and then your public IP address, because the other side needs to know your VPN gateway's IP address. So you create a public IP address table. I'll just say East Gateway public IP. And then there are a few things like enable active mode or configure BGP. BGP is it's a protocol. I think it's a border gateway protocol. So that gateway protocol is used for automatically identifying certain routes and populating those routes. So if you want to do that, you can enable that, otherwise keep it disabled. Okay. So far, so good. So this is the next step. So you create this, it will deploy this appliance. I have to do the same thing in the West region as well. I need to deploy a Vnet gateway in the West region as well. Makes sense? So now you have two devices, and then I need to specify the connections between them. Okay. So far, so good. So on the east side, what we have done, created a gateway subnet, and then we deployed a Vnet gateway on the east side. Right. On the west side, we have created a gateway subnet. We have not deployed a appliance. Right. So once I create this will start out deploying it in the east region. I need to do the same thing in the west region. Sometimes it might take a lot of time, like deploying the gateway sometimes takes 15 minutes to half an hour. Okay, but you get the idea, right? Because these steps might be, I just am saying, right? First, 2 VNets, then 2 gateway subnets, then 2 gateways, and then connection between the gateways. These are the 4 steps you need to do in order to establish your hybrid network, or in order to establish secure VPN to VPN, VNet to VNet connections across the regions. Make sense? Right, so while it is in progress, maybe I can start another portal, and then I'll deploy the west VNet in the gateway in the western region. If I go to the gateway again, you have to select the virtual network gateway. So east gateway is, I think, still in progress. Let's create a west gateway. You have to make sure that your region is selected correctly where your VNet is deployed.
Basic.
Oh, yeah. For the cost purpose. And I'm going to select the VNet West. Going to identify the gateway subnet there as well. Okay, and then public IP address on the other side of it. Let's say IP gateway on public address. Right. Once you're done that, the final thing you need to do is create a VPN connection. So VPN connection you can select in the services and say, this is this gateway, this is the other gateway, I want to connect them. So it will ask you the public IP of the other side. Make sense? So that's the way you can create a hybrid connections or secure VNet to VNet connections in your Azure cloud. Make sense? The routing things, connecting, designing networks can get complex sometimes.
This is lightly code.
Yeah.
Gateway connection. So what do you prefer, the parent or?
So that's what we'll talk about now. So now we know that like we can design our virtual networks. We can design our subnets based on what kind of workload, what kind of departments, what kind of resources you want to use, right? But then what are the good architectures and what you should do, right? So we are going to look at a couple of topologies, which is supported by Azure. This is like architectural topology. So any cloud should support that, but we'll look at some of the recommended topologies and why we should use that. One of the topologies which is frequently in use in very large organizations is called hub and spoke topology. In the hub and spoke topology, you have 2 components, hub and spoke, right? So you have central hub and then you have spokes. So hub and spoke topology typically looks like this. So you have hub, right, and then your spokes. Not good at drawing. And then everybody connects to the hub in order to get around.
So the transitivity is
Exactly.
automatic.
Right. So why it is important and where it is beneficial, right? Sometimes what happens in networking is you want to apply central policies, right? You want to apply central policies to, let's say, most of your networks, right? So now, if those networks are getting connected, you want to apply policies in terms of security, in terms of certain compliance, right? Now, You can do it, like for example, when I create this Vnet to Vnet connection, right? I can apply the policies here. But the problem is if this guy wants to talk to another Vnet, I have to apply the same policies here, right? And then if this guy wants to talk to here, right? I have to do this, and I have to do this, and I have to do this. It gets very complicated. Makes sense, right? So what Microsoft allows or Azure allows is hub and spoke topology, where hub can be used for all your central policies and compliance. So let's say you want to apply certain firewall rules. Right? You don't want certain sites to come into your network or on any of your VNets, for example, right? So you can create and deploy your firewall in the hub. And then whoever gets connected with the peering to that hub will automatically get this firewall rules. Make sense? So this is an example of like how do you deploy a common security across multiple VNets. You can create a hub VNet, right? And then you can create all other VNets and the spoke VNets. Then you deploy a firewall in the hub VNet, and then all other spoke VNets can connect, and then they don't need to do any other firewall settings because hub VNet's firewall settings are automatically applied to all the spoke VMs.
So they're all so connected outside.
Yeah.
That's how.
Right. So instead of doing, let's say you have 3 VNets which wants to talk to each other, you have to create peerings like this, right? If it was not transitive, right? So instead of doing that, what you can say is you will have one hub, and then let's do this, which will allow from here a traffic to here.
Do you sacrifice speed in there?
No, it's just a routing table, right? So it knows how to send that to the routing table. In fact, you can create multiple routing tables if your performance is degrading. Okay, so you can create this transitivity through the hub and spoke like this. Here's an example, like in a hub, you have deployed a firewall, right? And then you have 2 spoke networks, right? Which you want to do peering and apply the firewall rules.
So the connection is appearing, right?
Yeah. Makes sense, right?
So that means we cannot use the VPN gateway, right?
You can still use VPN gateway if you wanted to do that, but most of your security is there in the hub, so you may not have to worry about like encryption and everything. You can put in the hub virtual network. In this case, makes sense. You can deploy a VPN gateway in the hub and use that VPN gateway. Make sense?
Yes.
Yeah. So something like this. Let me show you. This might be slightly complicated one. But you see here, we have the express route or private peering here. The same thing can be done with here in the hub network. You just put the VPN gateway here, and then you put the VPN gateway in both of these sites, and then just connect to that hub's VPN gateway. You can still do that. Yeah.
Like the VPN gateway in each one of them.
Yeah, let me just modify this diagram to show you that. Might is slow. So what you can do is you can put a VPN gateway here. And instead of peering, right, you can deploy a VPN gateway here and then connect it. Make sense? Right? Because this will be again in a separate subnet. This will be a gateway subnet. This will be in a hub subnet, for example. Make sense? You can do all these kinds of things. Clear?
Yeah, it makes sense.
Right. So again, in short, like hub and spoke is really good architecture when you have like a lot of many VNets and you want to apply central security like firewalls and compliance and even the VPN gateways, etc. The good thing is because it allows the transitivity with just those radio buttons, you can use all of them. Makes sense? So you can say, I want to use the transit gateway, and then it will allow you to go through the gateway. Make sense? So you don't have to like do peering as well as hub and spoke, right? As soon as the hub is there, you can allow the transitivity between those.
I look like peering would be faster.
It's not faster in terms of like when you say peering, it uses the Microsoft network. The faster piece is where you have
Because you don't go through any gateway.
yeah, but we are going through a gateway for a reason. You want to encrypt your data,
Correct.
right? So when you do encryption, it's anyway going to take some performance away from you because every bit is encrypted before it is sent over the gateway, and then the target network has to decrypt it before using it. Makes sense?
Plus the volume.
Yeah, but then think about like firewalls, right? You don't want to deploy firewalls in each VNet with the same rules, for example, right? In fact, in Azure, you can create a hierarchy of firewall rules. So one can be at the parent level or the hub level, and then others could be at specific VNet level. You can create that kind of a architecture as well if you wish.
And when you say that, for example, when you do the firewall and the hub, you still have to say use this firewall.
Yes, so you see this connection. Right? It says use this firewall deployed in the hub. Make sense?
It is different than the gateway connection and the pairing.
Yeah. Yeah. You can when you deploy a hub firewall, you can say to so in this network, in the spoke network, you can say that I want to use a hub firewall from the other VNet.
So in other words, when you create a firewall in the hub, it would be an option in every VNet that you
exactly
that you create.
Yeah.
And you just have to choose.
You have to choose that. Yeah. In fact, there is something called a firewall manager, which allows you to manage those easily so that you don't have to like do a lot of stuff in configuring it. Okay, so far so good. Other topologies is like this hybrid topology, right? And there are a couple of other things we will talk about, and I'll show you that. Hybrid with express route is like, as we discussed, when you connect your on-prem to the Azure cloud, right? You have two ways to connect. One is through the the internet connectivity, right? The regular internet your data center can use to connect to the Azure cloud and Azure regions, right? And then that connectivity can be established through a VPN gateway, as we saw, right? Now there could be reasons why corporate may not want to use that connectivity. One could be the quality of the internet connection, right? Because then you're dependent on Xfinity or AT&T or some internet service provider, right? So so the quality and the speed, because it is shared, right? You may not get the same one. So if you want a higher speed, better quality, and better security, you have a option of using a private link, which is called express route. So what you can do is through express route, you can establish a private link between your data center and the nearest connectivity center. Okay. So what it uses is something called Azure Express Route Gateway. Okay, when you set this up, so you can see this is like simple, similar like a VPN gateway. This connectivity here between on-prem to this is establish something called express route circuit. And this is available through Microsoft's partners. It's not directly provided through Azure, but there are Azure partners in each region where Azure has POP locations, point of presence locations, and then they can establish a private link between there to that POP location and then there to the nearest region into Azure. These are called express route circuits. Circuit is like, why it is called a circuit? It's not a single connection. So it is like they have a primary connection and a secondary connection in case the primary connection is down. Okay.
It's a physical.
It's a physical connection. So they put the fiber link from your data center into the nearest POP location, and then Azure's partners maintain that express route. Makes sense? That's right. That data does not flow through internet, right? So it is guaranteed because it's dedicated between those 2 points, right? So speed and everything is guaranteed. For availability, they use primary and secondary routes. So that's why it's called a circuit, right? If this circuit is open, the data will flow through this circuit. Okay. And then there's a few other things on this diagram which I will mention to you. So you see here in the Vnet, right? You have a particular subnet where we have VMs deployed. Now, when we deploy VMs or servers, right? We want to deploy certain applications and run those applications there, which might be using some other Azure services, like maybe Azure Storage or Azure SQL or Azure Machine Learning or whatever, right? The question is, how do your VMs connect to the, for example, storage account? If you remember, last time I was talking about the storage account security, right? So if any application wants to connect to the storage account, right, it needs to use the SAS, right? The signature. You remember last time we created the signature and the key, right? So they need to have that key. Once they have the key, they can connect to that storage account and then do the stuff. The question is, let's say your storage account is created in US West. Your VMs are deployed in US East, right? And then your program is saying an HTTP connection. Makes sense? That connection can go over the internet, right? Or the Microsoft network, right? So it might use a public route. Are you with me? Right? So let me just show you. So if I go to a storage account, let me see if I have a storage account. Or we can create a new. But browser storage account. Let's create one. I'm going to create a storage account in our, let's name it as info tab. Let's do LRS. So when I create this storage account, right, I have blob storage, table storage, queue storage, everything available, right? My applications are, let's say, using these different kind of storages, right? So we were discussing last time, right, the keys and how to store the keys in the vault, etc., right, to access to that storage account, right? But the way your application is going to connect to the storage account is not through some IP address, right? They have a URL, a public URL. Make sense? So they will go over HTTPS and connect to that. That means your VM can go out onto the internet to connect to your storage account, or even the Microsoft public network to connect. Make sense? Right? So the question is, if your storage is sensitive data, right, and you have deployed everything in the cloud, how do you enforce that the connectivity between your deployed network resources and the storage is private and does not flow through the cloud? Or even if it flows through the cloud, how do you secure that or encrypt that? Makes sense, right? So if I go to this resource, for example, right now, let's look at its access key.
If it's not secure, why take it through cloud?
So you see here, right? If I pick up this one and then put in the notepad. Not this one. Did I copy it? Right, this is my endpoint, right? This is my account key, there is storage, right? So this is HTTPS, right? And this is my endpoint, google.windows.net or whatever, right? So when I tell my application to connect, it's going to use something like this, right? HTTPS, whatever, infotext storage 1. Let's say I want to connect to a blob, so it will be blob dot. Right? Now, from the access authentication perspective, I am safe because they'll be using this key, right, in order to access the account. Makes sense? Which I'm not sharing with anyone else. But still, my connection is going over the HTTP network, the public network, right? Now, how do I ensure that? So there are a couple of things. How do I ensure that it is going through the Microsoft network? And then how do I ensure that it has a endpoint? How do I ensure that I do not allow them or anybody else except these VMs to connect to that storage account? Makes sense? Anybody can connect, right? Using this IP, this network and this account key. Makes sense? But let's say
anyone can try to connect. They don't have access.
Yeah, but let's say they get a handle to my account key, right? Which is a separate thing, which we talked about last time, right? But let's say I have very sensitive data, I have my hospital data. I don't want it to go outside the hospital, right? So though I have this kind of a connectivity, I want to restrict. I say that nobody can connect to this except this particular VNet. Right? Meaning, I know that my all applications are deployed in particular virtual network. Who is going to use the storage? Then I don't care. I don't want anybody else to come to my storage. Right?
Mhm.
You can do this in networking using something called a service endpoints or a private link. So if you see here, what we are showing here is the private link. When you create a private link Azure, make sure that your data does not go outside the cloud, Azure cloud, first of all. Okay, and you can apply tools like only the Vnets which has access to establish this private link can do that. Makes sense? A private link is also works as an alias for any network. Okay, so what is a private link? So and you can create private link for any of these services which you have created. Okay, either you are using your Azure automation or SQL database or a storage or a Cosmos DB or whatever services are available. Most of the past services available in Azure will allow you to create this private link. Private link gives you a notion of as if that that service is deployed privately on your local network. Make sense? What it means is, look at this network. So this has a subnet 10.1.10.10.10.24. Okay. Now let's say suppose that this is the only subnet which is using my storage account. Okay. What I can create is a private link for that storage account. When I create a private link, what it will do is it will reserve an IP in my local network pointing to that service as if that is deployed on my private network. Make sense? So let's say 10.0.0.6 is an IP of my storage account. So any machines here can use this IP to connect to my storage account. Make sense? As if it is deployed in that local network, but it is actually pointing to a storage account wherever it is deployed. Make sense? Right? So even if I don't publish this, I can remove this and say this is only available through like this. Now anybody in that private network can only get to that IP. Make sense? Because nobody else has this IP address from outside.
They can.
How?
Declare the same IP address.
Yeah, but that's local IP address. It's not in that network, right? Makes sense?
If it's going through public, it has to have a public.
Which one?
So this for that's
So when you create this, right? So it's something like that. When you create a private link, right? It will disable all the internet access to here. So nobody can get in. The only way to get in is by using this 10.0.0.0.6 account in this particular subnet to connect to that. So anybody outside this subnet will not be able to get to that storage account. Make sense?
only makes sense to me if it's going through the Azure.
Yeah, it will always go to the Azure network. Makes sense? Right? So what will happen is anybody even types this, right? HTTPS, it will be resolved to 10.0.0.6, not in the public IP. Let me show you that.
How they control that between, for example, the share. Because you're on a server, there's two companies maybe on that server, for example. You declare your subnet with the same thing. I mean, it can be a coincidence, but and then you have the same IP and you're trying to connect. Then will you be able to connect? The same.
Well, we'll come to this scenario what you are talking about, but let me show you how to do that. So it might be very clear to you. If I go to the storage account, right? Go to the networking here. You see right now it says enabled from all the networks, right? I'll say enabled from selected virtual networks and IP addresses. Right, so basically your internet access turns off immediately after I do this. Right, so now I have to select which virtual networks can connect. Make sense? And then I can do that. But that's a service endpoint creation I am doing. Okay, so it is aliasing that service from these IP addresses. But let's say I want a private. So you see here private endpoint connections here. I go here. Yeah, I want to create a private endpoint. Okay, so now you say, okay, my storage private endpoint. And then there, say, where did I deploy that? Okay, let's see here. But I have East US network, so I can say here. Says target sub resource. Let's say block. Now I have to select the virtual network. You see here, if I take Vnet East 1, right, and I say I want to deploy this private endpoint into a default subnet here, right? Yeah. Now, and then it will ask you the DNS, private DNS. So if you want to like create a private DNS name, you can create that. And then let's create this.
We are defining the as that goes to it.
Exactly. So now what we said is that for this storage, right, I'm creating a private link from this. So now actually that storage will have an IP address into my private network through which my VMs in that network can only connect to that machine.
There's more to it, not just an idea.
Right, IPR, yeah. So now I can go to that storage account and disable all other access.
Mhm.
Right, so now it's only on this subnet, on this VNet, this subnet, this IP address, you can connect to my storage account and from nowhere else. Now your storage could be in a different region, doesn't matter. Makes sense? Even if your storage is in the west region and you're creating a private link in the east region, it will still work.
They couldn't do this through security group, like it just like you deny any access from outside, it's only have access from.
Yeah, but then the performance, right, where they would like evaluate everything before it goes there. And then the problem is, I'll show you. And that's where the service endpoint comes into picture. When you want to do that, you create a service endpoint and then define the rules. So if you go to NSG, you can say, one of the options is service endpoint there. So let me show you. So makes sense. This is how you can secure this.
I got
right?
it. I'm just trying to understand that question too.
Yeah. So service endpoint is another way. You can just create a service endpoint, right? And then say, many VNets can connect, right? But then who can connect and who is restricted, you can do through NSG in that
You
case.
can be more specific.
Yeah, you can be more specific and say NSG and that. So at least from the all other IPs outside your network, nobody will be able to connect
It's
to your
another
storage.
layer of security.
Yeah.
Like you have the NSG and then
And this is what a lot of organizations will be doing. And that's why I'm showing this the service endpoint, which is a kind of a public endpoint, and then a private IP link, because a lot of organizations, right, they want to have better control on their content, right? So storage account is like all their content. It could be, your patient files, your patient records, your patients, studies and things like that. Anything like your e-commerce data, for example, right? You don't want everybody to get handle on that, right? So you want your only applications to connect to that, but only through certain private networks. And that's how you have already set up in your on-prem data center, right? So you want to do that same thing on the cloud, you can achieve it like this. Okay, and then if you want to share certain information outside, right? Remember we created those signatures with the start and end date, specific time, specific IPs. You can then just expose them to the third party that way, right? But your applications which need the permanent access, you can always set up this kind of a security around it. Create a private endpoint and then connect. So that's what is shown in this infrastructure. These are some of the topologies of the architecture which we need to design properly when you're setting up the network and security and performance and things like that for your networks in the cloud. I'll share a few more topologies later on, like pure hub and spoke and how it works, so that you can go through that and understand. Once you understand, it becomes easier to follow the concepts. Okay. All right, so So that's the private endpoint creation. And then there's, like I said, like instead of private endpoint, if you want to create a service endpoint, you can create that as well. And then secure the access through your network security group from the subnet properly. So those are some couple of things you can do. Set up breakpoints. Should we take a break and then we'll talk about how do you diagnose network issues in Azure, because it might get very complex. One thing we have not discussed yet is another hub and spoke architecture, but it might be wide. Meaning, if you're like a global presence, right, and you want to, and you might have like a lot of different VNets into your different Azure accounts, you might also use a WAN group. So you can create a WAN. So you can create a WAN hub, which is basically a wide area network, right? And then different Azure regions. And then in each region, you might have different VNets. But the idea is same, right? You're creating a bigger network. So basically, you're creating a WAN connectivity where you may not have express route connectivity or poor internet connectivity. You want to use a WAN links. You can create your WAN hubs and then connect all of your networks through WAN. That idea is same. The hub protects you from a lot of things. It can be used as a global router as well, and other things.
So do you have spots in the region and then that's connected to the WAN app?
Yeah.
Connect.
Exactly. Yeah. So when things get complex, meaning if everything works, no problem, right? But if your problem like, hey, I'm not able to connect from here to here, what's going wrong? How do you diagnose that? In simple one-to-one networks, it's easy. One single region, it is easy maybe, right? But if you have like, hybrid network coming from the offshore, right, on-prem data centers, WAN network, and then multiple regions involved, and then you have like created multiple routing tables and multiple, firewalls and applied all of that. And if one computer cannot connect to another computer, you need to diagnose what's going wrong, where it is failing, where the packet is getting dropped off, right? So for that, you can use those diagnostic tools. So after the break, we'll talk about each of the tools and how it helps you to diagnose certain issues. Okay.
We have to have the infrastructure to refine that in your world.
Yeah. And that's why that network diagram is I like it.
Very important.
It's very important. You need to have that network diagram in front of you and then use this diagnostic tool to find out where the problems are. Okay. So take a 15-minute break and then we'll talk about the diagnostic tools next.
Naren, can you unmute yourself?
Okay, I did that. As soon as I asked you, I did. Okay. You had any other question? No, right? Okay.
No.
No, so just to repeat, right? So what we have covered is the core networking services, which helps you how to design a network or set of networks for the organization. So when you're looking at that, you need to think about like how many VNets you need, right? Within a VNet, are you going to create separate subnets based on your security and routing requirements? Like web servers is one set, database is another set, for example, right? And then you have to think about the connectivity, right? VNet to VNet connectivity, subnet connectivity, VNet to site to VNet connectivity, site to site connectivity, right? Again, all of that plays into with certain, constraints like what is security you want to apply, right? And then based on that, you will be working with, different virtual appliances, things like routers, VPN gateways, local gateways, and, so on and so forth, right? Things like, even designing your IP schema and IP address scheme, right? For each one of them will depend on how you're going to use that. Are you going to maybe in the future doing the peering with that, or are you going to do network to network connectivity on that, right? So all of that plays into picture. And then, as I said, additional services like firewalls, DNS, how you're going to put that into your networking strategy, and then different kind of topologies like hub and spoke architecture, peer-to-peer connectivity architecture, or for example, creating aliases or private links and service endpoints. All of that will play in that. So these are like some of the core concepts you need to know. And as I said, like some of them you need to practice so that specifically for the certification, when they ask, what are the steps to do this, or sometimes they say, we are trying to do this, we are at this step, what should be the next 2 steps, for example, in getting this done, right? And apart from that, you might get certain questions on diagnostic side of it. Like let's say, here is a given network, and then from this machine, I'm not able to connect with this machine. Which diagnostic tool you will use, for example, for this, right? So let's look at that. So for the diagnostic purposes, right, you have different tools available in the virtual networks, okay? We call it network monitoring tools. So, sometimes you might have surprised, like when you create certain things, right? You get few other resources like network watcher or automatically deployed for you. That is because of the network diagnosis. As soon as you do something with the networking, it deploys things like network watcher, right? And network watcher is the one which does the basic diagnosis and helps you to fix the problem. So I at least identify the problems, okay? And then the network monitoring tools, you will see things like IP flow verify or NSG diagnostics or next hop. And you can use all of these to identify and fix the networking issue. So for example, IP flow verify, right? It basically tells you how your packets are flowing between 2 IP addresses. If you want to use that, you can say, hey, I have this server in this subnet, which I want to connect to this server in this subnet, but somehow it is not able to connect. You can start IP flow verify to tell you at which IP it is getting dropped. Your packets are getting dropped, for example. If you are doubting your security rules might be in a way, right? You can use a tool like NSG diagnostic. As the name says, network security group diagnostics. You can use it to identify what are your effective rules for a given connection. And then based on the rules, you can identify where it is causing the problems and which NSG you need to modify in order to allow the connection. Next hop is basically a diagnostic tool targeted routers, meaning I want to go from this machine out, and I'm expecting it should go onto the internet gateway, but it is not going onto the internet gateway, it's going somewhere else, right? So I need to identify that when a packet is sent from this machine, where is the next hop? Where is exactly it is going? And then you can do hop by hop analysis using this tool, right? So this is basically a routing table diagnostic tool. If you have like multiple levels of routers, and then for some reason one of the routing rules is going to a wrong hop, right? Then you'll be able to identify that with this kind of a tool. Sometimes it is not that you're not reaching to a machine. Sometimes it is that you're reaching very late. You're very high latency between the two networks. How do I identify? It could be that in the routing table, there is some wrong rule, which is keeping you in the loop before it goes to the destination, right? So you want to identify those kind of issues, okay? If you want to troubleshoot VPNs, for example, right? Or VPN gateways, there's a VPN troubleshoot that. Packet capture is another utility. I don't know if you're like, if any of you have done the system administrator side. This is one of the key utilities people use, packet dump or packet capture. What packet capture does is that given an interface, it will capture every packet coming in and every packet going out.
It's like a ping, right?
Not a ping, but I forgot the name. Let's say I want to watch my home network and I want to see every packet coming in on my router and every packet going out of my router, right? I can do this by using certain utilities. One starts with F, I'm forgetting that. So it's similar to that. Basically, you need to deploy an agent and then say start a diagnostic on particular NIC. So anything coming in, anything going out is going to capture. Okay, this is useful when you think the connectivity is there, but somehow your application is not working properly. So it's like to do a deep diagnostic. What is happening? For example, I established, let's say, an HTTP connection between the two machines, right? And it is saying that this cannot be connected, but if I see the packets, it is coming in, right? But for some reason, some packets are getting dropped out, or they're coming out of sequence. It is not able to arrange in the sequence, or because some packets it is dropping because of some rule, it is not able to create the whole HTTP packet, for example, right? Or maybe I have two machines, but there is a hop in between, right? And then when these two machines are trying to connect each other, this hop is dropping some of the packets. So I can put packet capture on the hop and see why it is dropping some of the packets. It is supposed to go through that hop to the destination machine. Right? So you can do a package dump or package. TCP dump is an example of that. Right? So TCP dump is a packet capture. There's another utility I'm still forgetting. Wireshark. You heard of Wireshark? Exactly, that's what it is doing. Right? So Wireshark is a packet capture utility. Right? The similar packet capture utility you want to install and do it for a particular NIC for a particular range of time, you can do that using this diagnostic tool. Okay, and there are other things like connection troubleshooting and few more monitoring things. So monitoring is an optional thing, meaning if you enable that, it will give you insights. So for example, you might think everything is working fine, right? But monitoring will find that, hey, some of the packets have a very high latency, which you may not realize, but it can tell you that, hey, these packets have high latency. Maybe it's better to update this route in order to, get a lower latency, right? So if you want that kind of an insight, there's something called network monitoring or connection monitor you can enable, though it is at a price, but it are like different levels. So you can enable your level, and then it will give you different insights into what's going on into your network. It will also tell you if you're choking, meaning your network bandwidth is not enough, right? And you need to like expand your network bandwidth or reduce your network bandwidth for cost purposes. It will tell you that as well. Make sense? Network performance pointer does the same thing. Okay, so these are the tools you can use. So let me show you where those are available. So if you go to the portal, let's look at the network watcher. You see a network watcher service? And you will see as many VNets are deployed, it has started network watching services for all the VNets.
Or free by default.
They're free. The basic monitoring is free by default, so that it can perform certain diagnostics which you want. Right? So when you deploy a VNet, you will also get the network watcher deployed with it. Okay. And then if you look at the two sections, two blades here, monitoring and the network diagnostic tools. So let's say if I wanted to find out, or I wanted to use the IP flow verify activity just to see the IP flow between the two different VMs, right? I'll just go here, select my resource group, right? My virtual machine, because I'm not deployed any virtual machine, I'm not able to see anything. But if I've deployed a virtual machine, I can select that. And then if that virtual machine had a network interface more than one, you can select particular network interface. And then you do this. So local IP address and the remote IP address. And the particular port also. And then if you say check, it will tell you, if the flow is going or it is not flowing. Make sense? Same way if you do NSG diagnostic, for example, right? You can, again, the same thing, you need to get to, say, virtual machine, but I don't have any virtual machines. But you get the point, right? And then you can say your source IP and the destination IP. Okay, and then when you do NSG diagnostic, what you will get is the rules based on the direction. So if you say between these two IPs, what are the rules I have inbound, right? It will tell you the effective inbound rules. Makes sense? Because your rules can be propagated from many subways, right? So subnets, right? So you might have subnet level NSG, VNet level NSG, and then you have your server level NSG. So it will aggregate all the.
It is the order of them.
And it will tell you the priority wise which rules are getting fired. So if you have a problem, you can go to that subnet gateway, sorry, NSG, and fix that directly from here. Same way with outbound. Let's say some machine is not able to connect to internet, right? And you want to find out what are the outbound rules which might be affecting it. You can get the aggregated rules here in terms of in order of the priority.
Those are free services or?
These are free, right? The next topic is the same thing, like you specify source IP address, destination IP address, and say I'm going from this machine to this machine, but what is the next hop where my packet will go next based on the routing table? It will tell you. Make sense?
Gives you the
So,
hierarchy of the hops,
yes.
like to get from one machine to
No, it will tell you just your next hop,
just your next.
right? So then you can put your next hop in the source and then get your next hop. Right? We just want to check like why it is not going into the internet gateway, why it is going to the VPN gateway for some reason, right? And then you put the address, it will tell you like why it is going to a VPN gateway. Maybe there is a routing rule in between because of the peering connection or something, and you might have to fix that area. Make sense? Yeah. So effective security rules are also similar, but it also gives you a firewall in that. The firewall is blocking it, right? It will tell you here what are the firewall rules blocking you from here. Okay. VPN troubleshoot is around like VPN troubleshooting, right? If you have like a certain VPN gateway and you want to troubleshoot it, like what is the health, what is the performance of that, like encryption, decryption, etc. You can put. In fact, you can monitor it and then put that statistics into your storage account because it's going to generate a huge file. So if you want to put that file in the blob and analyze later, you can say where you want to create those files and store those files. Okay. Same thing, packet capture. This requires like some application. So you can add it to a VM and it will then deploy that application onto that NIC and then capture it. So it's not by default enabled, but let's say you had a problem and you had doubt that, hey, this guy is doing something with my packets, right? You can go and say add agent to that particular machine, target instance. And then what kind of packets you want to like capture, right? Make sense? I don't know if you've ever worked with Wireshark, you can like specify. Let's say I want to capture only HTTP protocol packets and not any other, right? I can specify like which TCP packets I want to capture from which machine to which machine. Right, so I don't want to, because on the NIC, there are millions of packets going every hour, right? And you have doubt between, let's say, two machines which is going through that hop. You can say, I want to capture all the communication between two machines which is going through this hop, not any other machines, right? So you can filter that out. So if you only capture that much what you're interested in, rather than you're capturing all the garbage. Makes sense, because there could be many packets going through a particular machine at any point in time, right? So you can specify, time limit as well, like capture for, let's say, half an hour, and then I want to do the analysis. Makes sense? So all of that you can set it up. So once you set it up, you see the storage account where it will dump the capture files, or you can put a file onto your file, some file share as well. So you can specify your file location or a storage location where it's going to put a packet capture file, which you then analyze with like Wireshark or whatever later on. Makes sense? So this is just a capture, not the analysis part of it. So you say, okay,
Is this like network performance where it captures your like logs?
yeah. So it will. So basically, this is for troubleshooting the network. So any packets going through, it will just capture and it will tell. It will also give performance statistics as well. So for example, something like this, right? I don't know, in TCP, if you're seeing communication, it will be like this. So a TCP packet, right, will have a source IP and the port, right? And then it will have a destination IP where it is going and the port. Make sense? And then the content. Now when you do a TCP communication, it's not like one packet communication, it's like start of, like I said, it will have something like start STX. And then it will say how many packets are following. So let's say one request has 100 packets, right? So each packet, so this has identified packets will have an ID, right? And then the content of the packet, ID, content of a packet. Makes sense? So now when this is flowing, right? It's a bidirectional, right? It is going from machine A to machine B, for example. It will have a timestamp. Packet 1 arrived at, let's say, 9:10, 00 seconds. Packet 2 arrived at 9:10 seconds. But this is huge. Why like 10 seconds between the two packets? Right? It could be that if you look at the other direction, because each packet needs an acknowledgement from the destination, right? You might see that from B to A, the acknowledgement for this packet, let's say, came after 7 seconds. That means something is going on the destination, it is not replying in time, and that's why this is taking a lot of time. So yes, you can do performance analysis based on this as well. Make sense? So packet capture has like a lot of utilities. You can do performance analysis. You can see why some packets are getting dropped, some packets are getting rebuilt, or what is the quality of connections and things like that. But for that, it needs to run a utility on your card, the NIC, and that's what this setup is all about. Hey, on this virtual machine, I want to start this, and then all the package capture should go somewhere in storage account or file from where I am going to do analysis later on. And then I can specify my filters. Okay. So once you say start capturing, it will start capturing from that time to whatever the seconds you specify. The different diagnostic utilities are available. If you want certain diagnostics automatically to happen, you can do the monitoring part of it. Again, the topology is what I like, as I said, right? You can create a first a topology diagram, right? Saying, hey, for the left one.
Oh, that's great.
Yeah, so you can select or maybe unselect all of them.
I think this helps with the statistics too.
Yeah. So first I will take this diagram, print it out, and then look at the diagnosis.
Sometimes you can see just the connections here.
Yeah, but like if
you
you're
have
like
a
a
wrong
very
connection.
very large and complex network with like 10,000 machines deployed,
No, yeah.
right? You can just take a picture and then look at it. But if you go to connection monitor, for example, right? There's some basic connection monitoring available, but then if you want to, create monitoring, right, you can do that, but it will be at the cost. Just remember that. Okay. The other thing is the performance monitor, which I was talking about, right, where you can use this service, right? Again, yeah, these are two same things. So connection monitor is the latest one, which gives the performance monitoring as well. Okay, but you can create a connection monitor, but then it's basically, you'll get charged based on that. So your subscription should have first right to create a connection monitor, and then you can do insights. As I said, the insights will tell you things like which connections are working, where your trouble, where your performance issues, right? And then it will also suggest you things like where to look at, like it will say how to optimize your routes, but it might ask you to, merge two firewalls together and make one firewall, for example. It will say, upgrade these routes so that you have a lower latency between these two networks and things like that. So if you want that, you need to create a connection monitor and then create those graphs yourself. And it will give you nice views as well as it will give you an alert. So based on that, you can create the alert saying, hey, if between these two connections, if my latency is more than 10 milliseconds, let me know. It will give you an alert whenever this latency is going high at particular day in time, etc. It will tell you so that you know what to do. Maybe I need to allocate more bandwidth, for example, or do I need to take care of that by optimizing certain routes or do something about it, right? So you can get the alerts like that from this. Okay.
What's the latency acceptable to?
Generally, when you're on the same VNet, you should be expecting 1 digit latency, 1 digit between 1 and 9 milliseconds. If you are across availability zones, it is still 1 digit. It goes up to 10, 15 milliseconds at most. Okay, but across regions, it might be higher latency. So it might be because it depends on like how the regions are connected, right? So if you have like a east region and the west region, right? A physical latency between those might be at least 5 to 10 milliseconds, which you cannot overcome. And then on top of that, based on what kind of traffic is flowing, you might have higher latency between those networks, right? So it depends. Now, you can reduce the latency by creating something called the networking groups or placement groups. I don't know if you're talking about that. So a placement group is something like this. I don't think they cover this in certification. Or in Azure, it is called sometimes enhanced networking. So enhanced networking or placement group are same thing. What it means is that, let's say you have an application, right? But your application is, let's say, 3-tier. So you have web server here, which is on VM1. You have an app server here, which is deployed on VM2. And let's say you have a database deployed on VM3. Right? Now, what happens is when your application is getting used, people are sending the request. It goes here, and from here to here, here to here, and then comes back, right? Because most of your data is stored in the database. So if somebody says, hey, give me a list of all the TVs, right? It will go through these layers and come back here. Make sense?
Mhm.
Now, think about this. If this is in a different VNet, so let's say this is VNet 1, this is VNet 2, this is VNet 3. Even if they're in the same VNet, it might still apply. Let's say latency between these two VMs is 5 milliseconds. Latency between these two VMs is 5 milliseconds. That means you've already introduced 10 millisecond latency. Makes sense? And then on top of that, how many requests you're getting and what is the bandwidth available? Your users might be crying at this point. It's too slow, right? Now you think like, hey, I put a 1 Gbps network here, 1 Gbps here. Why it is still having a high latency? It is simply because your VMs are deployed in different data centers, right? And different data centers means they might have a high latency or physical latency, right? Then how do you make sure that let's say you want to tell Azure that, hey, all these 3 VMs, because they need very close connection with each other, right? Every request is flowing through all the 3, right? I want them to be near to each other. How do you tell it, right? So when you create a network or when you select VMs, right, you can say, put these VMs into the same placement group. What it means is that when Azure sees that, okay, this group of VMs you want to put in the same placement group, it will try to deploy all the VMs on the same physical box. Right? So you have 0 latency. Make sense?
Mhm.
So placement group or enhanced networking is used to decide if those VMs should be near to each other or it doesn't matter. Make sense?
Yep.
Right? So when you do placement group, that means the latency is 0, almost 0 between those machines, because your application needs those connections to work. Right? If you create a connectivity like this, it's going to be very bad. No matter what you do, your users will see a slowness in response. But you want to put them together, right? Or maybe on the same data center or within the same under the same physical infrastructure. Yeah, Viral, your question.
Yes, I was wondering where do we have that option for the placement in a portal?
Yeah, so when you create the VMs or the VNets, there is something called enhanced networking. I'll show you that later on. Okay, but that's what you do it when you want enhanced networking. Make sense?
Yes.
Okay, so just remember this, because this is what sometimes people forget, like when they're designing applications, if their application is 3-tier, right? You don't want distance between the 3 tiers, because every request might be going through all the tiers.
How do you minimize the latency from the user itself?
That's not in your control, right? Because this is coming through internet, right? If the user, let's say, 1 Mbps internet, is their latency, right? Makes sense. The way what you can do as an application developer or an organization is you deploy your application near to the users. So if your users are in US West region, then your application, your VM should be in the US West
So
region.
that's why I asked the question, like now you are doing like the physical placement in the same place.
So even in the US West regions, right? Let's say you have 3 availability zones, right?
Mhm.
So let's say, so that means that 3 data centers, one is in, let's say, LA, another is in San Francisco, and another is in Sacramento. If your database is in Sacramento, your web server is in LA, and your application server is in San Francisco, you're introducing a latency.
Correct.
Right? So that's why when you do this, you just say that these 3 I want in the same placement group. So what it will do is not only it will deploy everything in LA, it will also make sure that if possible, all your VMs are created in the same physical underlying hardware. So you do not have any latency between those. Make sense?
I understand that. Just like how to optimize the latency from the user. Do you like deploy it into AWS from the 3 layers? Like
Yeah. So even
redundancy?
if you create 3 availability zones, right? Basically, what you are doing is like creating three duplicates of your application. Right?
Redundancy.
Yeah. Yeah. So what you are saying is my application is replicated in the 3 availability zones, right? But in each availability zone, I want to put them in the same placement group. Make sense?
Mhm.
So they are near to each other within the data center, for example. Right? Okay, let me see. Okay, one of the other aspects to the networking is load balancers. I think we talked about this a bit on the VM virtual machines, right? When we created the virtual machine skill sets, right? Where you can create like multiple replicas of your virtual machines or applications, and then you want to distribute the load. When you want to distribute the load, you need to deploy a virtual appliance called load balancer, right? So load balancer is used for distributing the load between your replicas or application copies, right? For the incoming traffic. Now, typically you have 2 kinds of load balancers. A physical one or a virtual one. Okay, nowadays people use virtual one because the performance of virtual appliances is now almost similar to the physical load balancers. And then when you work load balancing, right, you're basically routing the traffic, right, to different instances so that the load on each of your application server is kind of similar and manageable, right? If you face more load, then you want to deploy more machines behind the load balancer and let load balancer do the balancing. When you talk about the load balancing of the request, right? If you look at the infrastructure level, it's the packets, right, which is going through from one machine to another machine, right? So how does this load balancer work? So they typically do load balancing on 2 layers of networking. So we have 7 layers of networking, right? If you look at most of the typical load balancers, they either work at the layer 4 or layer 7. Okay. So in Azure also you have 2 kind of load balancers available. One which operates at layer 4 and one which operates at layer 7. Layer 4 is the TCP/IP layer. Layer 7 is the application layer. Make sense? In the OSI 7 networking layers, layer 4 is the TCP/IP layer, where actually some sensible packets are available to do something. And then layer 7 is the application layer load balancing, right? Where we have application level protocols. For example, when you say HTTP is a application layer protocol. It's a layer 7 protocol. TCP is a layer 4 protocol, right? So
Do we have to remember all those?
layer 4, layer 7, definitely you have to remember because they're 2 different kinds of load balancers. Yeah, we know.
So is the layer 4 load balancer is a private?
No, both can be public or private. Layer 4 or layer 7 can be public or private load balancers, Okay. When we say public or private, basically what it means is what kind of traffic you're trying to load balance. Or load balance. Are you trying to load balance the internal traffic, which is the private traffic, or you're trying to load balance the public traffic, means the internet traffic? Typically, the layer 7, because it uses HTTP, are called public load balancers, but they can be used for internal HTTP distributions as well. So it doesn't matter you use layer 4 or layer 7. They can be both used as, public or private load balancers. Okay, but generally in Azure terminology, layer 4, we call it internal load balancer, for example, or public load balancer, or external load balancers and things like that. Okay, but both can work on layer 4 and layer 7. The only difference is that layer 4 load balancing is happening at the TCP/IP or the TCP packet layer. Layer 7 happens or load balancing happens in the HTTP protocol layer, which is the application protocol layer. Okay. Layer 4 is therefore faster. Okay. Because no, so the way it happens, right? You know the OSI model of the layers, right? So the first layer is like hardware layer, right? Then you have a media layer, data link layer, and then you have TCP/IP layer here, right? This is called a layer 4. And then I think, what is this? I don't know. And then you have session layer and the application layer. Session. The app layer. So this is the layer 7. And this is layer 4. So what we are saying is that if two machines needs to communicate, right, it uses this layers. Which my data first gets. So let's say I want to send an HTTP request, right? When I say HTTP, google.com, right? Make sense? Mm-hmm. And I'm saying I'm sending some search query saying, hey, give me the top post LED TVs. Right? That's my HTTP request. So on the browser, I'm making a layer 7 request. Right? Now my HTTP packet has the whole request. My request could be, let's say, just randomly 10 KB request, right? Which might have HTTP headers and session information, session ID, and everything, right? But that whole request doesn't go on my wire, right? And on wire only you get it 0101, right? The hardware layer. Right? So how does that get translated to 00001? And then the destination, like the Google server, gets this streaming 1010, then starts assembling that. And then at the app layer, when it has assembled all the packets, it will get my 10 KB information. Makes sense? Now at hardware layer, this might be going in 512 bytes. Right? So 512 bytes means for 1 KB, I need to send 2 packets. Makes sense? And for 10 KB, it will be 20 packets. Makes sense? So let's say the TCP layer, let's say your TCP bandwidth is 512 bytes. So when I say one HTTP request at layer 7, that means it's a 20 TCP/IP packets I need to exchange between the two machines. You agree? So this will be divided into 20 TCP packets. Each packet will have some part of a content. Each packet will have 512 bytes out of my 10 KB. And each packet will have some overhead. It will have source IP and destination IP because it needs to know right where to go. Source IP, port, destination IP, port, right? And then the packet number. Because destination needs to know how many packets are coming. So when this communication is happening, right, on layer 4, this layer does not kick in until I have 20 packets. Make sense? So when this 20 packets are getting assembled at this layer, Once those all packets are available, then they get assembled as a HTTP. Makes sense? So each packet goes from here to here, right? And it needs to wait until all the 20 packets are available. Then your operating system will send it to the upper layer. Make sense? Right? So now think about this load balancing. If I do a layer 4 load balancing, how does it work? It works based on the TCP packet. Right? So TCP packet has a source IP and the port and destination IP and the port. Right? So it knows which destination it needs to go to. Right? But if there's a load balancer involved, this is your load balancer. Right? So the load balancer, as soon as it sees one packet, right? It can send that packet to a machine, right? And then based on the source IP and target IP, it can start sending those TCP packets to different machines. Make sense?
But it doesn't do persistent, doesn't go to the same machine.
No, it doesn't do persistent. The only persistent it does is basically based on the source IP and the target IP and then the packet number. Because in order to get the HTTP request, all the 20 packets should go to the same target. Makes sense? Otherwise, there is no point assembling this, right? Right? So it does only that much persistent that it knows that, hey, when I started this TCP communication, my first packet went to this machine. So I'll keep sending all the packets to this machine so that it can assemble it properly. Makes sense? Right? So TCP IP load balancing is faster because it does not have to wait until the HTTP layer. Makes sense? Right? So you can choose between the two. If you want faster, you can do layer 4. But then that has certain restrictions in the app, like you should not have session persistence and things like that. Okay, so you can use either layer 4 or layer 7. Make sense?
Layer 7 is slower.
Yeah. So the layer 7 application load balancer in Azure is called an application gateway. So there are two terminologies you will use in Azure. Load balancer, which is typically a layer 4 load balancer, and application gateway, which is specifically a layer 7 HTTP load balancer. Okay, so two different kind of load balancers available in Azure. Okay, but as you know, right, the job of a load balancer is to distribute the load, distribute the packets between the backend pool of servers, right, where your application is deployed. Okay, so it's to balance the traffic. Right? Internal versus external. Internal means it is load balancing your internal packet. So let's say your internal web service, right, which is load balanced, and it goes to the internal Vnet. Then you can put an internal load balancer in that, or you can. So an internal load balancer will have, let's say, only a private IP, but not it will not have public IP. If you want an internet-facing or public-facing load balancer, you will deploy a front IP, which is a public IP, for example. So that's the only difference. This is a typical diagram, right, where your public load balancer, and then which is getting the load on the HTTP traffic, which is 80 and 443 ports by default, and 80 is HTTP port, 443 is HTTPS port. Okay, and that basically distributes the traffic between your web servers, for example, which might be in the public subnet, right? And then you might have an internal load balancer, which might be taking the traffic from here and then load balancing within your internal web service or whatever in the private subnet. Okay. So what are the other key points? So when you want to deploy a load balancer, what it means is first you create a load balancer appliance. Okay, based on your needs, you can create an application gateway or you can create a regular load balancer. Once you have that load balancer, you need to now tell the load balancer how you want to balance the traffic, which is called a rule. Okay, so you establish a rule. And then you need to tell what are the target machines, right? Where you want to distribute the load. So which is called a backend pool. So terminology is a backend pool is set of servers, right? Where you want to distribute the traffic. Load balancer is an appliance, right? Which will do that. How it will do is based on the rules which you create them. In addition to that, it will also do things like health probes. So for example, one of your machine is down. You don't want to necessarily now distribute load to that machine until that machine comes up, right? But then how does the load balancer know that machine is down, right? So for that, you have something called health probes. So you can set up a health probe between the load balancer and a backend pool, and then it will at certain period of seconds, it will keep checking. Okay, if the target machine does not reply within the time frame, it will assume the target machine is down, and it will keep it out of the backend pool until it comes back. So it will not stop the health probe, but it will not just distribute the traffic once, and it will keep checking that machine. If that machine comes up, it will automatically put that back into the backend pool. Makes sense? There are a few other advantages of or few other duties of the load balancer at layer 7, which happens. We'll talk about that in a bit. But let me see here. Yeah, let's create one load balancer and we'll go through those concepts. So I'll go to the portal. And then let's look for the load balancer first. Okay, so you'll see load balancers here, right? Click on that. Right now, we don't have any load balancer, right? So let's create one. Let's click on create. So our resource group for today's labs. Yeah, but you can still create this. You can still create a load balancer. So just name it as like, a web load balancer, for example. And then select a region where you want to deploy a load balancer. There are 3 different SKUs you get, right? Now, one thing just to remember in Azure Cloud, when you use a particular resource, and if you see something still like SKU, that means that SKU defines what kind of functionality or features you will get along with that. Okay, so if you say standard SKU for load balancer, that means it has certain things, right? So for example, standard load balancer allows you to connect 1,000 machines in the backend. But if you do not have a requirement for 1,000 machines, you want to just load balance only a few of them, you can use a basic load balancer SKU. So basic load balancer SKU, for example, only allows 300 VMs to be load balanced maximum. But it might be fine for you. This SKU means your load balancer cost will be less.
No, then that's okay.
Yeah, so you need to look at some documentation. Okay. So it will do, and you might have things like comparison, let's see, scenario here. Like for example, if you use a standard load balancer, right? It is only NIC based, this is IP based as well. Makes sense, right? And it can do health probes on these 3 protocols. This cannot do HTTPS health probe, for example, right? Let's see what else. SLA is there. Here, there's no enforced SLA. You're paying less, right? So based on that, right, you can decide. So whenever you see SKU, that means there is some costing implication on and the feature implications of what you are using.
So there, I didn't see any limitation beyond.
It should be there. I think it's this one. See, another limitation is like this. Standard virtual machine resource availability set resource or virtual machine skill set. So in some of the things, like in basic, you might not be able to use VMs across multiple availability sets. You can only use one availability set as a load balancer backend tool, things like that. But let me see the limit. There should be a limitation. But I definitely remember 1,300 for sure.
It's okay, we can.
Yeah, you can check it. See if it is available.
Here we go.
See, standard is 1,000.
Contact the
And then the basic is
still 1,000.
no, these are
Right.
load balancer is 1,000. See, this one like 300. See, backend full size is 300. Single availability set. Right? If you see here, it will be 1,000.
300. So that's 1,500 for resources.
Yeah, but front-end IP is 600 and 5,000. Rules per NIC is 300. But where is the 1,000 limit? They should say 1,000. Oh, 5,000, sorry. We increased it. There's 5,000, sorry, not 1,000. So these are like some of the things you have to work as an architect. It may not be a certification thing, right? You don't have to remember the limits, but you need to know that there are some certain differences between the SKUs. Okay. Anyway, so we are here. Right? So now once I give this information, it will ask me to front-end IP configuration, right? Meaning load balancer will have some kind of an IP, right, where you want to connect to. So let's say if I want to create a front-end IP connection. Yeah, so I'll just say, front-end IP configuration name is FPIP1. And then you see virtual network it has picked up, and then the subnet where it will be deployed. Right, and I can say assignment add. Okay, so this will be deployed in the this VNet and this subnet. It will have an IP address from that. Remember, we are not deploying a public right now. It is going to a private IP. You can assign a public IP as well if you want later on. Okay, but this is an internal kind of load balancer I'm creating right now. But it's a layer 4 load balancer. And then you specify the backend pools. Right now, we don't have the VMs. Otherwise, what you can go to and say add backend pool. It will ask you the backend pool name. So I'll say, my web servers, right? So let's say. And then I will add the VMs here. So these are the target backend pool machines, which I want to load balance. Okay, so it's unable to find IP configuration that matches the criteria because in this, right, I do not have any VMs deployed. If I deploy the VMs, it will be available here. Make sense? Right. But I think I should be able to still save this without anything. Means I can add it later. Okay, I just create a backend pool and front-end configuration. Right. Now I can provide the rules. You can provide and add a load balancing rule here. Incoming rule, right? So when I say incoming rule, that means what is the rule name? So I'll say my rule name is rule 1, for example. And say IP4 front-end IP address is this one, which I created. And then backend pool, I'm not, I created, but it's not available. Right? Didn't I create? Oh yeah, this is it, right? Here's my backend pool, right?
Mhm.
So what this rule says is your incoming request is coming to this front end IP address. You're connecting to this servers using which protocol. So you say, I want to use TCP protocol. Which port? Which incoming port the request will come to? So let's say on load balancer, I say my incoming request will come to port number 80. On the backend pool on my VMs, and where you want to forward this request to, and on which port,
Mhm.
right? So it is possible that when you deploy your application, your HTTP application may be deployed on port number 8080 on your VMs, right? So if that is the case, you say my backend VM's port number is 8080, not the 80. Okay, there's something else you can do for security, like when you deploy your apps, deploy an 8080 port, and then let load balancer front with the 80 port, and then send it to the 8080 port on your machine. Okay, but if they are same, you can keep the same as well, like from 80 to 80, 443 to 443, for example. You can create a health probe here as well here. Okay, right now I don't have it, but I can create a new one and say, hey, health probe name is just a ping. I want to just use a ping to do a health probe, right? I can say protocol use the TCP or HTTP. I can use TCP. You see, there is no HTTPS because we are in the basic SKU, right? And then every how many seconds I want to do the health probe, right? You can change it. Right now, by default, it's 5 seconds. So,
Which is low.
yeah, which is generally it's okay, right? So now it will keep checking my backend servers every 5 seconds. So if I have 10 servers, right, every 5 seconds, it will probe each server and see if everything is working. Okay, if the server or target machine does not respond, right, it will put them out of the backend pool. But it will keep checking every 5 seconds to see if they're coming back up or not. Okay, so this is how you specify the rule. Okay. And if you want, you can specify the outbound rules as well. Okay, this is typically used for the net or network address translations if you want to do through your load balancer. But as far as load balancing the load, we have done everything. Right? We created a backend pool, we created a load balancer, we created a rule on which port the request will come, where in the backend it will be sent, and health probe. Make sense? This is how you create the load balancer. Okay, I'll leave it an exercise for you to really, if you wanted to deploy some web application and check it, you can create a VM in the backend pool, deploy a web server like Apache, and then use this load balancer to do, to connect to that machine.
I did it last week.
Oh, you did it already?
Yeah.
Okay, that's good. Okay. So this is how you set up a layer 4 load balancer. Okay, if you wanted a layer 7 load balancer, I'm not going to create it for now, but let me show you another one. It's called application gateway. Now, the good thing about the application gateway is it's not only layer 7 HTTP load balancer, it allows you a flexibility in load balancing a lot of other stuff. It doesn't have to be your own application deployed in Azure. You can actually load balance your on-prem applications using this load balancer. Or you can, if you deploy anything on the app services, or if you deploy something using Docker, for example, you can load balance those things as well using this load balancer. Okay, so that's the main thing about the application gateway. There are a few other things it can do. So let me show you while creating. I'll show this property. Let's click on create. So when you do this, source group, to give the application gateway name. I'll just say my region. Let's do US. And then again, it has a tier, standard or WAF or WAF2. So remember here, if you deploy your application gateway, you can deploy using a standard tier, which is like a standard SKU or standard V2. So there are some feature differences slightly. But you see another two, WAF and WAF V2. This is, if you wanted to front your load balancer with a web application firewall, you can do that as well. So let's say I want my load balancer, but with the security of a web application firewall. Then I can select one of these keys or one of these tiers. So not only you will get an application gateway, but application gateway fronted with the web application firewall. You guys know what is a web application firewall, right?
Mhm.
Right. So web application firewall is a specific firewall which allows you, which basically protects you from certain web attacks, like for example, DDoS attacks and DOS attacks and all of that, right? You can deploy a web application firewall. So it's a specific software which will monitor your request based on that, and it has like intelligence of its own. So it's like machine learning and AI and things like that. And based on that, it will protect you if somebody is trying to like spoof or somebody is trying to launch a DDoS attack, it can protect you from that. So if you wanted that protection, you will use one of these. Okay. For now, I'm going to use standard. Instance count. So this is a scalable gateway. So you can specify, and this is, so by default, it will have 2 instances. That's what, because of the standard tier. If I do standard V2, you'll see you can do enable auto scaling. Means as your load increases, it will automatically scale your load balancer as well with that. Make sense? Right? So if you want auto scaling as your load increases or decreases, you can go to standard V2 and select that. And then specify the count. These counts are not how many applications it is load balancing. These counts are the count of the load balancers itself. Okay. So how many instances of load balancers? If you wanted to fix it, you can fix it. You can say, hey, no, I want only 2 instances, or I want only 5 instances. Make sense? Right. But if I choose a standard tier, I don't have that option. I'll only get 2 maximum instance counts for the load balancer. But I'll be paying less. Right. You see, queue size is medium. You can make it small as well. So if you see,
What's the
yeah,
in price wise? So, for example, let's say I put the wall and I put 2, minimum 2 and maximum 2. So now I have, like the auto scaling there, but it's going from 2 to 2.
here, like this. WAF or standard you're talking about?
Which one has the standard V2 or something?
Standard V2 has an auto
The
scaling.
auto scaling, yeah. So that if I do that and I say 2 to 2, is it a difference in price or?
Oh, here you mean like if I just do
Yeah,
2 and
2
2,
to 2. So what's the difference between the?
then there is no difference between standard and this, but there might be other features which might be disabled because you chose a standard tier.
That's why I'm saying you can choose this and do 2 to 2, and then you have the same thing.
No,
But you have more options.
you might have more features related to this, which may not be enabled because you chose standard versus V2. Make sense? So this tier does not only affect enable auto scaling, it affects other things as well.
That's my question. Will this be more expensive by doing this?
Yeah, it will still be more expensive. Though your instance count is only this much, you are also using other features which is not available in standard. Okay. HTTP2 is a new emerging protocol. So if you want to enable it, you can enable or disable. By default, it is disabled. And then you can see a virtual network where you want to, for example, configure this or deploy this, right, in which subnet. And then you define the front ends. You see, it says front ends. meaning you can have more than one front-end IP attached to this load balancer. And then you can have public, private, or both. Okay, so just to answer Viral's question, you can make your application gateway also private if you wanted to. Okay, if you want it to be public, then you need to create a public IP address for this. So let's say if it was a web front end, I'll just say web front end PIP. It will create a public IP through which my users will be connected to this load balancer. And then same in backends. Now here, if you look at backend pool, you have more things here. So you can say, one. So you can say add backend pool without the targets, yes or no. If I say yes, it will not ask me anything. I can set it up later on. If I say no, I want to set it up, you see the options I get. I can put any IP address here. It doesn't have to be my Azure IP address. So if I want to load balance my on-prem servers, I can put the IP addresses here and load balance all these on-prem. Okay, or I can have mix of them, like some IP address from the on-prem, some IP address from the Vnet. It has like a lot of flexibility around that. I can also select my virtual machines as usual. I can also select app services. So for example, if I did my pass, right, means the application as a service, I deployed applications, right, as we say, so in the compute, right. I can load balance my app services as well with this, and combination of all of them, right, and I can put them behind as a backend. Make sense? But for now, we don't have anything, so I'm just going to say yes here and then add. And you can keep adding the targets. Okay. Now let's go to the configuration. So your front end, you can add more front end IPs if you want. Okay. And then you can do a routing rules. A few more flexibilities here as well. Okay. So let's say my rule number 1. And I can put a priority. So you can have more rules with different priority. Now there's something called a listener. So in load balancers, you just saw the port, right? Here you can add a listener. It's a similar thing. It is saying that this load balancer will listen on certain port for incoming request. So you're saying incoming request will come where and who will listen. So you're saying my listener 1 will listen to this public IP address on port number 80 or 443. Okay. So you can load balance between HTTP and HTTPS here. So you can say, so let's look at HTTP 80. You said my things are coming here. Okay. And then you can say a basic or multi-site. You see, it's multi-site. I can load balance multiple applications using the same load balancer. Okay, based on the host name. So pay attention here. Let's say I have 3 applications. Okay, I have hr.app.com. Okay, and then I want this application to run on 5 virtual machines, 5 instances, right? Then I have sales.app.com. I want to deploy this on 10 virtual machines. Okay, and I have e-commerce.app.com. I want to deploy it on 100 virtual machines. I can use single load balancer to do this load balancing. I can say if request host is hr.app.com, incoming request host name is this, load balance between these 5. Send the request here to this backend port. If it is coming for this, send the request to this backend port. If it's coming for this, send the request to this port. So this load balancer is load balancing 3 apps with 3 different ports. Make sense? When you want to do that, you can use the multi-site. and you say what is the host name, and then what is the backend pool. Okay. But if you want to use a single site, basic, you can say it like this. Basic is single or multiple. There is another one. In the multi-site, you are single or the multi-part, right? And then you can create the host name and things like that. There is another way also you can do that is by using a different path. So this will be same, let's say app.com. You can do it something like this as well. And then say /HR or /sales or /e-commerce. Using this path also you can do different backends. Okay. But based on that, you can select it. If I keep it basic, it will say, okay, it's a single one, so it will not ask me for the host name, load balancing, and then add. Backend pool, I created about settings. Oh, I can add a new backend setting. So in the backend, I can say, on the backend, where does it go to the backend port, right? So I can say backend settings 1. And then I want to connect to the target machines using the 80 port. So my incoming request is 80 going to the 80 port on my target machine. My app is deployed on 8080, I'll just say 8080. Makes sense. And then few other things. You can do session affinity or the session persistence on the application gateway using these two settings, cookie-based affinity, right? If you say enable, that will tell you, it will ask you what is the cookie name on which I should do this persistence. So you can say whatever cookie you want to set, you can set it, and then it will use that cookie to set the persistence or session persistence from. So in load balancer 4 or internal load, sorry, not the layer 4 persistence happens based only on the source IP. Layer 7 persistence can happen based on the cookies. So you can set up a cookie-based persistence. And then things like request timeout is there. You see the backend path I was talking about, right? / something. You can put it here. And then you can create many backend ports like this with like different paths. Make sense? So based on that, it will send the request to a particular backend port. So this is very much flexible, much more flexible and much more advanced features load balancer. Okay, so application gateway is the right one to use if you want to load balance your internet load with all these features. There is one more feature here, which let me show you that. Let me add this. And then let me go again. So one more feature is if I do HTTPS based load balancing, right? I can create a certificate and upload a certificate for using HTTPS. What it does is it creates a HTTPS connection between the load balancer and the user load. Okay. So let's say your application you want to be secure and to be available on HTTPS port, right? There are two ways you can do that. So this is your load balancer, right? And then your user load is coming like this. And then your server is here, right? Which is load balancer. So when the HTTPS request comes on, basically it's SSL based. So SSL certificate has to be installed. So you can install your SSL certificate on all of these, right? But then the problem is all the HTTP request when it comes here, it gets encrypted and decrypted on individual servers. Make sense? So your server has to do encryption and decryption, right? In order to serve that request. What you can do is that you can offload this SSL part to the load balancer, and you can install SSL certificate here. So the communication between load balancer and on your server is non-encrypted. This is HTTP. But the communication between the load balancer and your users is HTTPS based on the certificate. So you are installing certificate here on the load balancer, right? So that means the encryption and decryption is done at the load balancer layer. So your application servers are free to do other things, right? So this is like centralized, right? And then takes the load off of your backend server. This is why it is called SSL offloading. This is what it used to call. Now they call it TLS offloading because we use the TLS certificates now. Okay, so this is another facility available when you use the application gateways. Make sense? Right. So if you do HTTPS load balancing, it will automatically do the SSL offloading as well.
So what the guarantees of the load balance? What's the guarantees for
SLA, you mean?
I mean, how much traffic can what they guarantee?
Yeah, so it depends on like how much
I mean,
bandwidth.
SLA is more like time to respond.
No, SLA is like how much is available, right? So for example,
Availability.
so availability is like if you're done like auto scaling, etc., it will be 99.999%. It will be available. Now, how fast it will be, right? Meaning, yeah, how much traffic it can handle is based again on that auto scalability, right? Meaning, if your SLA is typical SLA is like certain milliseconds, right? Certain milliseconds between the request arise, request is received, or the packet is received by the load balancer, right? To sending it to the backend server. That can make sense? Means the average wait time or the queue time on the server is in few milliseconds, like one millisecond latency, for example, right? But in order to maintain that, right, it needs to scale. If your user load is more, and if you're not set the auto scaling, right, then it might start dropping.
Why I thought about that is because if it's handled with certificate, then that's latency can increase.
Yeah, you're on layer 7, so latency is already increasing because you're not on the layer 4 load balancing, right? But the problem is like, not the problem, but the issue is like this. This is your load balancer, right? It's not going to take unlimited load, right? So it has a certain, so that's why the SKU is very important. So SKU will tell how much bandwidth is allocated. So if you're within that bandwidth, it will handle the request within 1 millisecond. But now let's say you're going beyond the bandwidth, right? You have more requests coming in. That means this 1 millisecond might become 5 milliseconds.
So the queue that you choose is
right. So now you have two options here. You can say if my load increases, I want to do auto scalability, right? So then it will scale automatically and then serve additional requests to make it within 1 millisecond. Makes sense?
scalability is the virtual machines.
No, that's what I was saying. This scalability is for the load balancer scalability, right? I want to auto scale if my load on the load balancer itself is high, right? So then you can auto scale it if you have that comes. Makes sense, right? In order to maintain that SLA. Okay. All right, so I think we talked about this. The last one is content delivery network. I think this is not much here, but basically this is for improving the application performance, right? So let's see, this is our last topic in the network, so we'll just talk about it. So there's something called CDN, if you've heard of it, content delivery networks. So sometimes what happens, no matter what you do, right, your application is performing slow because there's a physical latency which you cannot avoid. So let's say, for example, your users are in US West. So you deploy your application in the US West region, right? Good, fine. So let's say your data center in LA, right? So all the LA users are happy because they're the nearest one, right? But maybe somebody in San Francisco, right? There is still a physical latency between San Francisco and LA, right? So now the problem is he's not getting the same performance as LA users. We know the reason why, right? So now, what if I wanted to improve the performance of these guys and make it same as LA guys, right? The only way is I have to open a data center in San Francisco and then somehow send the content which these guys are looking for, right? And that's what the CDN is all for. So in certain applications, when you want to, when performance is very important, right? You want to bring the content as close as to the user to minimize the latency. Okay, so my application might be deployed in LA, but I can copy that application in San Francisco if I had an option, and then serve them from here rather than here. Right. So for this, Azure or Microsoft has something called POP, point of presence locations. So apart from the regions and availability zones and data centers, where you can deploy your applications, etc., you have something called POP locations, which are many locations across the country. So for example, in US, it will be like if we are in Illinois, we will have 3 or 4 POP locations near to us, like for example, Chicago or edge locations. Yeah, so in AWS, we call it edge location. Right? Same thing here, POP locations, point of presence. So they are like minimized version of data centers. They're not full-blown data centers. Their only reason of being there is to cache the data which is there in some other location. So it's a copy. So to copy certain data or content to serve the users better, right? You can copy the content from a particular region to a POP location.
After the first request.
Yeah. So what happens is when this guy, right, wants to access the application, it will go to the nearest POP location. If that content is not there, the POP location will download the content from the region and then serve from here. So once it is downloaded, any other user is looking for that request, it will get it from here rather than going to here. That's how the Netflix and other things work, YouTube and all of that, right? Because nowadays you don't see any latency in Netflix, right? Immediately it's available because it's your content is near to you. The downside is that you cannot have the full load. So Netflix cannot put all the movies in the cache location. So that's why you're monthly rolling for different cities or where you are, because they can only put certain movies onto that cache location.
Or because they pre-do it.
Yeah.
It's not on demand.
Or it's not on demand. They just push it.
Correct. They push.
Yeah, they push the content and then you watch that content and after a month the content changes.
I think they do it both ways.
Yeah.
They do it
You
like
can do
on
push.
requests.
Yeah, or on demand also you can do that. So it's something like this, right? So for example, your origin region is this one. And Alice is your first user. It will say, hey, I need to get the content. First time it is not there, it will download it from here. And then when other users try to load the same content, they get it served from the POP location. Make sense? Right? So this is the distributed network of the servers where you can cache the content and serve from there. So this is another way of improving the application performance, right? When your users are looking for quick connectivity and quick response to some of the critical parts. So you don't want to cache everything, you cache only things which are like mainly or mostly used by the users. And second thing is the things which do not change quickly. right? So this is the pop locations are good for static content like Netflix, right? You want to cache it for a month, all the movies, right? But certain applications which rely on database and which changes every day, you don't cache that things here. Makes sense? So it depends on what kind of content you're serving, but as far as that content is not changing within few seconds or within few hours, it is a good option for you to use the pop locations for improving the performance of your applications that way. Make sense? Right? And then you can design your applications to use these pop locations. I can say my images will come from pop location, my static HTML, CSS, JavaScript will come from here, but my database content will be fetched dynamically. So you can do part of it. And part comes faster, part comes slower. You can do it that way as well.
What's the rule for updating in Azure? Like for the pop location?
So what you do is like when you create a pop, right? You can specify how many pop locations you want to use. Makes sense? Because basically it could be that, let's say all of your users, your primary users are in US West. So you deploy an application in US West. But let's say there are some users in US East. And then there are some users in, let's say, US Central. But there's nobody outside US. So what you will do is you will push your content to all the pop locations in US, but not in Asia and Europe where you don't have users. Because your cost is based on how many times you are caching, or how many pop locations you are using. Makes sense? So you need to select which pop locations you want to use to cache your content. Okay, if you use all of them, and then you don't have users in other 90% of the countries, you are wasting your money. Makes sense? So you can do that. I think those are, and I have a review questions for this. So what I would suggest is as an exercise or homework, try to answer these questions. I'll put the answer keys tomorrow for the review question. Okay, so there are review questions all about your networking. Okay. So that will be your homework. And then next time, I want to continue a couple of other things with the networking, which is not in our slides, but I saw that they are now including the 104 exam. So we'll talk about that. It will not take more than 15 minutes, but after that, we want to move on to a different topic about security. Security we have covered a bit, but I want to cover most on the Azure AD because Azure AD has now a good significant coverage in these exams. It was not there like before, like even in the architecture exam, they didn't ask too much about the Azure AD, but seems like in administrative exam, they're asking 15% of the content based on Azure AD and the role-based access. So we'll cover that next time, okay? And then we have, I think, 1 or 2 topics left. So I think by end of January, we should be done with our content, okay? Any questions before we close today? If not, then enjoy the rest of your weekend and Happy New Year, everyone. Hope everybody joins next time.
Happy New Year.
And I'm going to post the exercise and everything next week. Okay.